The next layer of solving equations that we're going to work with is when there are variables on both sides of the equal sign. So not just one side. Our goal is still to figure out what the value is for the variable, but there's a little bit of extra work. Some of you may remember the bags and the coins from previous lessons. Remember, the bags represent the unknowns. So we have 3 unknowns on this side and 2 on this side. To be able to figure out how many coins are in each of the bags, we have to get rid of the unknowns on one side. So I'm going to cross out 2 bags on that side. And remember, properties of equality tell us if what you do to one side, you have to do to the other. Now I can see that one bag has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 coins in it. The second example, there are again 2 bags and 3 bags. So we are going to cancel out the bags on this side of the equal sign. And if we cancel out 2 on that side, we have to cancel out 2 on this side. But now we're still left with 3 coins that we have to get rid of before we have the unknown on a side by itself. So I'm going to cancel out 3 coins here and 3 coins here, and now we can see how many are in each bag. So we can say that when solving equations with variables on both sides of the equal sign, the first thing you need to do is to get rid of the variables on one side before solving. So that is what we showed with this bag problem. We subtracted 2 of the bags, so it's like we're subtracting 2 unknowns. And that's what we are going to be doing to solve equations. Let's look at some examples. The first thing you're going to do is, of course, divide your equation into 2 sides and look to see if you have variables on both sides, which we do. I generally get rid of the lesser, so 5x is less than 7x, so I'm going to get rid of 5x. Getting rid of in math is subtraction, so I'm subtracting 5x from both sides. It's like crossing out the bags. So that cancels out. I'm left with 5. So 5 is a part of the expression that hasn't been canceled out. I'm going to bring that down. And 7x minus 5x. If you have 7x's and you take 5 away, you're left with 2x. This is multiplied, so we have to divide to get rid of it. So we are left with x equals 5 halves. This looks like a fraction because it is 5 halves, so we can leave it 5 halves, or we could write 2.5. Actually do that division. And then we can check it. I'm not going to show that step today, but we could check it, remember, by putting this value in place of the x's, working forward to check it out. Second example, I'm going to divide my equation into 2 parts, and I'm going to look for my variable. Here's a variable, and here's a variable. So I have to get rid of one of the sets of variables. I usually get rid of the one that is the least, so I'm going to subtract 2x from this side to cancel it out. If I can't subtract 2x from one side, I have to subtract 2x from the other. On the left side of the equation, the part that is remaining is 30, so I'm going to bring that down. And now I'm going to simplify the other side. 6 plus 4x minus 2x. So we have 6 plus 4x minus 2x is 2x. Now this is a 2-step equation that we need to solve, so we have to remember how to solve. We look for that variable, and we have to get rid of whatever's furthest away. So we're going to get rid of that 6 by subtracting 6. 6 minus 6 is 0, but we're not going to write that 0. We're just going to cancel out and bring down what is remaining on that side, which is a 2x. And we're going to simplify the other side. 30 minus 6 is 24. Now x is being multiplied by 2, so we have to divide by 2. So x is 12. And again, we could plug that back in for x to see if it makes a true statement. Third example, we are going to look for, after we divide our equation in 2, we're going to look for our variables. Here's a 7x on one side of the equal sign and a 5x on the other side. Again, I generally get rid of whatever is the lower of the two. So it says 5x, so I'm going to subtract 5x. If I subtract 5x from one side, I'm going to subtract 5x from another. So 7x minus 5x is 2x, but I also have this plus 2 still on that side as part of the expression. Now I have 12 plus 5x minus 5x. The 5x's cancel out, so I'm left with 12. Here's a two-step equation again. I'm going to find my variable. I need to get rid of whatever's furthest away, which is the plus 2. I'm getting rid of whatever's added or subtracted first. So I'm going to subtract 2. So now I have 2x equals 10, because the 2's canceled out. X is being multiplied by 2, so I have to divide by 2. So I'm left with x is 5. And again, I could plug that back in for the x's to check to see if it makes a true statement. And my last example. This one is a little trickier because I see parentheses. The parentheses tell me that I need to do some multiplying first. This is the distributive property. So I'm going to start with using the distributive property. 2 times x is 2x. 2 times 4 is 8. And then I'm going to rewrite the rest of the problem. And I'm going to separate my sides, and I'm going to look to see if I have variables on just one side or both. I have variables on both sides, which means I have to get rid of one of them. I'm going to get rid of the x because it's the least. So 2x minus x is x, but I still have that plus 8 over here as part of the expression, so I'll rewrite that. 16 plus x minus x, the x's cancel out, and I'm left with 16. Now this is just an easy one-step equation. It started out pretty complicated, but now it's just a one-step equation. Here's my variable, 8 is added to it, so I am going to subtract 8 to help me find out that x equals 8. And I could plug that back in for my x's up here to see if it makes a true statement. I am going to show you the check step for this one, just to remind you. We can do 2 times. We think x is 8, so I'm going to plug that in. Now I have to do it on the other side too. 16 plus 8. 16 plus 8 is 24, and here I'm going to do parentheses first, order of operations. 8 plus 4, I wrote a 25, is 12. 2 times 12 is 24. 24 does equal 24. So that checks out, and this is our answer. And that's it.